Alright, let's see if this works. Let's pause this. Let's pause this. Let's pause this. Okay. Let's pause this. Okay. Let's try to increase the volume, and I don't know where the volume is on this. Whoops. I think it is, but maybe here, maybe? Let's try this out. Let's try this out. Does this sound better? Try this out. Does this sound better? Try this out. We might be able to increase it here as well. Let's see. Increase it here as well. Let's see. Yeah, does this sound better? Yeah, does this sound better? Yeah, does this sound better? Okay, that's some weird stuff going on. Sound testing and all that. Alright. Yeah, so today we're gonna carry on with our Pytorch tutorial thingy, I guess, and just trying to understand the basics. Let's start our project, and I also got a new shell, which is pretty cool, so I can just type this and this happens. But either way, let's see into our folder, which is Pytorch. I think it's underscore tutorial, right? Nice. Let's find it then. I think I can just do that. Yeah, and I got this. That is not what I want though. Oh, this is pretty interesting. Let's go to Pytorch. I think it's tutorial. Let's see that. Let's see it into project files and see what type of files we have. Yeah, this is the directory I want to be into. So let's open this in Visual Studio Code. Alright, I think I want to change my theme as well. Let's do that. I might just want to have a normal theme, to be honest. Let's go with the default dark plus one. I think that's fine. Yeah, let's go with that. And remove this terminal. We can also, now we can actually have that there. And if I just run this, let's see if this works. It kinda did, nice. Okay, so we're back at where we left before. Okay, great. So let's see, what should we do today? It's optimizing model parameters. Alright. Let's do that. Start locally. I don't think this is where we want to be, but that's fine. Go to, I guess, tutorials. Yeah. Yep. And then we want to go to optimizing model parameters, I guess. I just want to check if this sounds good. This is pretty interesting. Let's go to Pytorch. I think it's tutorial. Let's see that. Yeah, that's pretty good. Nice. Good. Very nice. Alright, so optimizing module parameters, I guess. Now that we have a module and the data, it's time to train, validate and test our module by optimizing its parameters on our data. Training a module is an iterative process. In each iteration, the module makes a guess about the output, calculates the error in its guess, which is the loss, and then collects the derivatives of the error with respect to its parameters, as we saw in the previous section, and optimizes these parameters using gradient descent, or descent, I guess, yeah. For a more detailed walkthrough of this process, check out this video on back propagation from 3Blue. I will actually go to that URL right now and just see. Yeah, I'm gonna save this URL to my latest, I guess. Yeah. So let's create href, I guess, or a hyperlink. And I think I did that up here somewhere. Let's see. You can actually just search for href here, and there we go. And this is okay. So this is basically the href and the. Let's go down here. I will just paste it down here. Moment. I will watch this tomorrow probably, and then explain this to you guys. And I'm also gonna go to the link again and copy it as well. Nice. And we'll put it here, and then back propagation documentation. Back propagation. Oops. Documentation. Like that, and if I click on this, I will probably open Shore, and I will get a tube. Yeah, that's nice. Obviously, this won't be nice for us. Okay, now that's all done. Let's copy this text here and just paste it in our document, and we will format it later. And I think that's fine. Yeah, that's fine. So let's do that. Okay, nice. Yeah, that seems to be a good start, I guess. So let's see the code here. So prerequisite code, which is the code we used before. Let's create a subsection here, or subsection pieces. Like that, and paste that in here. This should be numbered as well, which means that I have to remove this dot, I guess. Yeah. And this should only be a subsection actually. Nice. Okay, so the first thing they do, okay, we load the code from the previous sections on the data loaders and build the module. So we import Torch. This is kind of a recap, I guess. We import Torch, and we also import the neural network library. We import the data loader utility from torch.utilities.data. We import also their Torch Vision and the Torch Vision.transforms. And this is not what I want to click on. Jesus. Then we get the data, training data, we get the test data. We initialize the training data loader and the test data loader with some default settings here. We create our own neural network, or custom neural network here, with a linear and a ReLU layers. This function here defines the structure of the neural network, and this defines the functions that we use on the input data. And then we just create a variable which is equal to this class. Very simple. So let's copy this and import it in here. And I think that's basically the code. Let's save that, and boom, we have all the code here. We also actually we should not use that text either way. Let's try this, but I think I can create a new Python. Oh Jesus, we are in the data file. That is not what we want. The project files. So let's create a. What do we want to call this? Let's call it nnnn.py, I guess. And then move it over. I think it can be here. Nah, move it over here. It's fine. You know what? Let's move it over here. And then just get this whole thing here. And move this a bit. Nice. So we import the necessary libraries. We also create the test data and training data here. We initialize the different data loaders, and we create our own custom neural network here with different non-linear and linear layers, which is here with the different dimensions, or the correct different dimensions. And then we create the logic function for the input, and then just create a variable to this class. Yeah, pretty straightforward, not gonna lie. Let's run this. This should probably not. Yeah, it shouldn't do anything because we have already downloaded all the data and stuff. So that is fine. Okay, so hyperparameters. Hyperparameters are adjustable parameters that let you control the module optimization process. Different hyperparameters values can impact module training and convergence rates. Read more about hyperparameter tuning. So we introduce some hyperparameters, which is basically constants. Which is constants that help us train or have default settings, I guess, adds default settings to the neural network. And they are essentially usually like batch size and stuff like that. So let's check this. Okay, let's create itemized like that, and then we want to have a number of epochs in one of these. Also, okay, so we create number of epochs, which is the number of iterations the module should be trained in, and then we also, I think I pressed some weird button. And then we catch the batch size, which is the number of data samples propagated through the network before the parameters are updated. And then we just have the learning rate, which is essentially, let's see, learning rate, which is how much to upload module parameters at each batch/epoch. Smaller values yield slow learning speed, while large values may result in unpredictable behavior during training. Which means that we want to find a balance between those, which might be a bit difficult. But let's try this out. So, in the example here, we create three constants, which is learning rate, which is 1 to the power of 1 multiplied with 10 to the power of minus 3. So it's basically this number here. And then we have a batch size of 64. You usually want to use 32 or 64, depending on what type of neural network you have. And epochs is just 5. You can change this to 10 if you want to. At some point it's not necessarily better to have a higher value. And then we're gonna optimize the loop, I guess, or the looping function. which is essentially just once we set our hyperparameters, we can then train and optimize our module with an optimization loop. Each iteration of the optimization loop is called an epoch. The epoch consists of two main parts: the train loop, which iterates over the training dataset and tries to converge to optimal parameters, and the validation/test loop, which iterates over the tested dataset to check if the module performance is improving or not. Let's briefly familiarize ourselves with some of the concepts used in the training loop. Jump ahead to see the full implementation of the optimization loop. We will actually go through the whole thing. I think that's a better way to do it. Wait, what's this? Yeah, it's just normal text, right? Yep. Let's change to the PDF as well. Oh, it kind of lags out. The PDF should be here. Nice. Once we set our hyperparameters, we can then train the optimize our module or model. Oh, I think I need to add this here actually. Just like that, and then add the itemized list. Yeah, that looks a lot better. Let's copy this and just paste the whole text here, and then I will rewrite this to give a more general, I guess, explanation to it, and also to make it more personalized than just copying it from the whole documentation from the beginning. Otherwise, you guys can go and read the documentation by yourself and not read my PDF on my future web page. But I will fix that in the future. We can skip this line of text here. And then we come to the loss function, which is essentially just a function that calculates the loss, which is the accuracy, I guess. Subsection here, which is the loss function. And the loss function, when presented with some training data, our untrained network is likely to not give the correct answer. Loss function measures the degree of dissimilarity of obtained result to the target value. And it is the loss function that we want to minimize during training. To calculate the loss, we make a prediction using the inputs of our given data sample and compare it against the true data labeled value. Common loss functions include NNN.SEL loss, MSE loss, mean square error for regression tasks, and NNN.NLL loss, which is negative log likelihood for classification. And we also can combine with NNN.cross entropy loss, combines the log softmax and the NLL loss. We pass our module inputs logits, and obviously these different strategies depends on what type of module you have, and also what type of purpose your network should have. So it's important to use test different loss functions depending on what type of network you have. Either way, I think we should just copy the text here, and then I will explain the rest. But it's quite straightforward, to be honest. It's not that hard to understand, I think. At least I think that. If you guys don't understand that, then write in the comments and I will try to explain. Either way, I will, after this tutorial, when we have gone through all the all the information, then I will also try to dig deeper into this and create a better article from the beginning as well. Oops, my bad. I think that should be fine. We have to, I think I'm outside of the, where is the flush thing? Do I even have that? Wait. I don't. Interesting. Let's do this then. I might perhaps be able to. Jesus, this is a long freaking. I think this should be enough, right? Yeah. And if I do 2 of these, I should get a space between here. Yep. Nice. And then we can also move this down a bit. Nice. This is some code. We will copy this and just paste it in here. That should be fine, I think. And then we have the optimizers. With another subsection for optimizers. Okay, optimization is the process of adjusting module parameters to reduce module error in each training step. Optimization algorithms define how this process is performed. In this example, we use stochastic gradient descent. All optimization logic is encapsulated in the optimizer object. Here we use the SGD, which is the stochastic gradient descendant optimizer. Additionally, there are many different optimizers available in Pytorch, such as ADAM, and RMS prop, that work better for different kinds of modules. Let's see how these are characterized. How to use optimizers, and here we have different optimizers. 0 grad step, perform a single step up. This is a lot of different. Okay, there is actually not a lot. Never mind. For each has fused. ADAM. This is. I actually have to try this. I'm actually planning to build my own neural network and try these different optimizers with my own data, which I can do, but that will be for another time. Okay, and I think I also watched this video before. That's pretty cool. Oh yeah, anyways. So let's see where we are in the. Okay, so we just started. Nice. Let's copy these, and I will also paste the link for the different optimizers. Nice. We also want to create an href here, or a hyper link, which is up here. Let's copy that. And where is the hyperlink in this text? It is in the different optimizers. So let's go there. Where? No, there is. Additionally, there are different optimizers which is available. So let's create a hypertext here and just type here different optimizers. I hope I spelled that correct. Now this is becoming a link, and let's just go to this link here and copy it here, and I think that should be fine. Just like that, and if I press this now, I will eventually go to the main documentation. Nice. And then we also can So we initialize the optimizer by registering the module's parameters that need to be trained and passing in the learning rate hyperparameter. So we create a constant which is called optimizer, and that is equal to torch.optimizer.sgd, which is the type of optimizer you want to use, and then add the module parameters and then the learning rate. Pretty straightforward, to be honest. And I think I have to, yeah. And then we have that. Now we should also create begin, which is this here, to create some code. Let's copy this code and just paste it in here, and that's fine. Either way, I think that's fine. Inside the training loop, the optimization happens in 3 steps. So let's just copy this here and paste it here, and then create an itemized list here. Oops. So we call the optimizer.zeroGrad to reset the gradients of the model parameters. Gradients by default add up to prevent double counting. We explicitly zero them at each iteration, which we reset them basically every iteration of the training loop. That's pretty fair. I would also do that myself, just to get the same standpoint, I guess. Yeah, it is these tokens here. I think that should be fine, yeah. And then we backpropagate the prediction loss with a call to loss.backward function. Pytorch deposit the gradients of the loss w.r.t each parameter. Well, that now stands for. I'm not completely sure. Either way, backpropagate the prediction loss with a call. Yep, nice. And then the last thing we do is, once we have our gradients, we call optimizer step to adjust the parameters by gradients collected in the backward pass function. Very nice. Yeah, and also this is type wrong. Alright, nice. And I think we also have to, since this is not flushed to the left side, I also have to create 4 of these just to create a new line. And that didn't work out at all. Interesting. Maybe I have to do it here. Is that the problem? Nope, it is not. Wonder why. Let's do this then. I think I can do something like this instead. And then type it like 0 centimeters here. That should be not fine because this is not classified as a text element. Yeah, let's do this then. Let's create this item list like this instead. If that didn't work, let's do this then. Nope, we don't want to create an item list, we just want to add it to this list instead. Okay, that seems to be okay for now. And this is the whole implementation, essentially. So let's do that. And by the way, this only... a simple example, this is not nothing advanced when it comes to this type of project, because there's a lot of different more advanced projects, and we will also do those type of projects later. Okay, that seems to be good. Oops, bad. So let's save this. Shouldn't cry now. Nice. Let's see. Okay, so let's copy this whole code. Let's put this down a bit, and also create this begin, which is gonna be list thingy, and just add this whole thing to the. I think I have to move this step back about a bit. It seems pretty fine, and I also. This is a test loop, so this is not. This should not be, this whole thing, I think, should not be inside of this function. I think that's all, actually. Okay, it should be inside of that function. Interesting. But I don't think the code is done, actually. We initialize the loss function here. Right, it's here. Obviously, he's gonna cry because of these underscore or whatever it's called. And now it should be fine. Very nice. And I think we also have to do something like this. Okay, let's do this then. A new line. That didn't work out either. Okay, I'm gonna push all of this to the left later. But let's just carry on at the moment. And this is the whole thing, so it will essentially print the result. So let's add another. Begin here with the thingy and add that. Boom! Now we have the whole code. And now we also want to test it for ourselves, and then we are done with the optimizing of module parameters. And then we're gonna save and load the module as well. But let's add all of this code to this file. So we're gonna just take the whole implementation and add it above this whole thing, and I will explain the whole thing for you guys as well before we even test it out. Just so you guys get the just so you guys get the fundamental perspective of this whole we didn't import the libraries. That's my bad. Let's go and do that. So it's these libraries we want to use. Boom. So now we should be fine. The train and test data loader is not defined. We can define these by, I think we have to, is the, okay, so the test, so we still have to use this code here to define the class and also the train and data loader. And then we create the module or model. And I think that's all actually. Hyperparameters, I think we have those defined. We don't. Okay, let's define those as well. This should be beneath this module, I think. Like this. And then we also want to initialize these loss functions as well. Let's do that. And I just opened the whole frickin' initializes the cross entropy, and then we create an optimizer. I wonder where this optimizer is actually put. Optimizer, it's here, so it's fine. We have to use this as a parameter, so we need to predefined before this function. Yeah, I think that should be all. So let's test this out, and then I will explain it to you guys, and I will remove this as well. So let's, you know what, let's test this out in our terminal actually. So let's cd int our project files. Let's type, and then what's up, Daywang? It's another day. It's another programming day, and we're gonna try out the neural network we just created. So we're gonna run. We're gonna type Python preuse, and then we're gonna run the op.nnn.py file. Let's see what happens. So we're basically training the neural network right now on the different data that we downloaded from the Torch Vision data pack, and then we essentially trying to iterate it in a number of epochs to train it over and over again, so it can learn by its loss function, so we can get an accurate output data, I guess. The reason though, and this is something you have to take notice of, is that the answer here is gonna be quite accurate, but if we had more complex data, it wouldn't be, because I'm using my CPU now to train the whole thing. Daywang, I didn't forget you, dude. What do you mean? Of course we talked last week. It's another day, man. I will also stream tomorrow, by the way. I didn't forget you, man. But how is it going, dude? How is it in India? Let's see. I actually forgot how many epochs we used. I think it's 5, right? It should be 5. Let's see. Yeah, it's rainy as hell here as well, dude. It's super rainy here. But it should be better tomorrow. And I hope so, because I'm gonna go to church tomorrow. And by the way, the epochs is 10. So let's just wait for it. And we should probably get... I think we should get different images of the fashion minist mod dataset, which we predicted, so we can predict like a t-shirt and a sandal and stuff like that. So we are basically doing image prediction here with our own custom neural network. And the loss, as you guys, I can scroll up here. So the loss, as you guys can see, is greater in the beginning, but it becomes smaller for every epoch we do. So it's really working, to be honest. So accuracy is 67.1%, and the average loss is like 90. It's like 8% or something. Really interesting. So we are on the 9th epoch, and we are soon ready. It should pop up. I think it should pop up a diagram of some sort. I think, unless I have to fix that. Let's see. We're in the last epoch here. Yeah, it's super rainy, I know. It's raining here as well. And then after this, I think we have some more optimization things to go through, but later. Oh, it's done. The accuracy is 71.1%. Are you involved in the research or research paper in general? It really depends on what type of research paper you mean. If you're talking about the research paper I'm writing, it's my own, so it's not like something official I've done. It's just a fun thing to do, and the reason why I'm writing my this latex paper is because of students at the university, so they can learn neural networks easier and also faster. So I'm basically just doing this for fun and helping other students out. That's really just my own cause, I guess. I am writing one, but I am still working on it. This is just a template, my man. This is just a basic template. I'm gonna go in deeper. I haven't published any. I might do that in the future. I will see. I might, but I will. And I actually will publish it on my personal website in the future, so you guys can go to the website and look at it. I also have written some personal. I've also written some summary research or summary papers on some university subjects as well. So you guys can go and learn about discrete math and also physics and electrical circuits, and also those three have I done. I'm also gonna write a paper on what is it called? How do you say it in English? It's basically calculus, but more different. Yeah, I actually have shared the paper with you guys. It's on my GitHub at the moment, and it's all public. You guys can go read it. The link is down in the description, so you can just go and check it if you want to. It's definitely not done. It's still in the progress of work. It's still in progress, but you guys can go and check that out if you want to. And I'm also gonna publish it on my website when the website is done as well. And also different companies, if they are interested, can go and read that as well. So that is why I do it, why I'm doing this. Plus I'm learning my basically stuff myself. So I'm being generous, or trying to be generous, helping myself out by writing articles, and also try to write 2 to 3 published paper as you can get admission in uni aboard. No, that's fine actually. You know, I think I have the the competition from Sweden is very low. Are you talking about India or something? Are you talking about the competition in India from Sweden? Or like what type of universities are you talking about? By the way, we should go and save and load the module, by the way. Because the competition to Japan is very high, so I have to study a shit ton of math. Yeah. Oh Jesus, I just zoomed out in the whole PDF. Yeah, India is very nice. It's cool and it's actually brilliant, but I have a bigger interest in Japan at the moment. Or Italy, actually. Italy should be very nice as well. That is just my interest, but India is very cool. I would like to visit India someday. It's a very interesting country, to be honest, and it's very different from other countries in the world as well, since it has its from then 1 million apply for IT, but only 10,000 are selected. From Sweden. Is it from Sweden? Specifically. Okay, so in this section we will look at how to persist module state with saving, loading and running module predictions. So we are obviously gonna import the... No, grad is trash here. Go to Japan or USA or Germany. Yeah. I don't want to go to USA because I don't like that country, but Japan and Germany is very good, and I would like to go to Japan for sure. And I will probably get a good enough camera to document the whole thing actually, so you guys will also be able to see it as well. That is my plan. So I'm gonna try to get a decently expensive camera to record the whole thing and make vlogs and stuff. That is my plan, at least. I'm gonna list here. That will be like from 1 year now. So it will take me a bit of time. And even if I'm able to go to that country, I want to, but it's difficult now. It's a big competition specifically at my university. You almost have to have top. Why is this crying? You have to have. You almost have to have top scores to go to Japan. So I will try my best. So we obviously import Torch and Torch Vision with the modules and stuff. And then we want to saving and loading lightweights. So we are not saving the entire module, but we're saving like it's a lightweight version of it, I guess. So we're gonna put a subsection here. Yeah, but Japan and Italy is very cool. Italy is because I have family down there, and Japan is just because the culture, you know, and the food. That might be weird, not because the IT or something like that, but just because like the culture and food. That's kind of funny for me, at least. Okay, so let's see. Learn parameters. Is this let's see if this. Nope. Learn parameters. Let's see. Learn parameters. It's the dictionary. Okay. So let's change that. But I appreciate you asking, Daewon. I really do. Thank you for asking, and I really respect India. Even though there are some scams, you know, I definitely respect India because of how basically how they respect their own traditions, you know. Really, it's really important to have specific traditions. Let's see. Yeah, okay. So we should create and I think I did that. No, I didn't. Okay. And I also respect Japan for their traditions as well. They are very strict, and I definitely respect that as well. Something that Sweden doesn't have is strict. Let's see. So let's see if we can do this. Even Sweden doesn't have very strict traditions, so it's good to come to a country that has one. Save .py, I guess. We're also gonna import the modules as well and just see if this actually works or not. So we're gonna run this. This probably will give us an error because we have no. Oh, never mind. Interesting. Okay. So what is this? Open anyway. This might not be the best decision to take. Let's see what the path is. You know what? Screw that. Let's read that. Okay, the load module waits. You need to create an instance of the same module first, and then load the parameters using load. Okay. So let's just fix these so we don't get too many errors. I think that's fine. Yep. And this is also a problem, but I will fix that later. I think that's fine. Okay, so let's add this code, but we essentially create or we get the module from modules. Wait, Jesus. From VGJ16, we do not specify the weights because we want to create an untrained module. And then we load the state from this path. So we load the module with this path file, and then we evaluate the module, and then we will see basically the structure and stuff. So let's do that. This is not the file I want to be in. And what if we... You know what? Let's go here and just clear this whole thing and see. We want to start the save ln.py file and let's see what happens. Okay, nothing happens because we probably have to print this, I think. Let's print this whole thing. And start this file. See if this works out. Yeah, that worked out pretty good. So we have the sequential, the different modules, I guess, and this is a really big neural network, as you guys can see. This is a sequential. This is a sequence of layers, which is a different type of layers. Very interesting and advanced neural network, actually. And this is the classifier and the feature. Interesting. Very interesting. Saving and loading modules with shapes. So let's go fix that. When loading module weights, we needed to instantiate the module class first, because the class defines the structure of a network. We might want to save the structure of this class together with the module, in which we can pass the module and not module state.dictionary to saving function. So we can essentially just do that instead, and then we will have the structure as well. It's really good and very convenient for us to do to save and loading with shapes. So let's do that. And obviously it's gonna say, oh, something is wrong, oh no. But it's probably because this function here. Yep. Now this whole thing became... That is not what I wanted to do. What do you mean? Let's... Oh, in the Pytorch.latex file. Let's open this latex file again. Scroll down to the bottom. Bada bing, bada boom. And then we open our... Are you serious right now? And then we want to open this as well. So now we have our document here as well. Nice. Saving and loading with shapes. Okay, so we go here and check. So we can just type torch.save module with this name. So we save this module with the shape of its of the module with this name, essentially. We can also then load this module with this command here. Just like that. And I think it kind of lagged out a bit, but that's fine. And then we can just do that. Nice. Yeah, that seems to be fine. And I will always also flush this to the left later. Okay, so we have only one page left, and then we have the Pytorch YouTube tutorials, and then we have learning Pytorch. We can just go check this. Here we have a lot of different tutorials, I guess. We can actually go through this later, I think, but not today. We will do one thing more, and then we will probably end the stream for today, and we will start with the more advanced topics tomorrow, I guess. So Pytorch custom operators landing page. Pytorch offers a large library of operators that works on tensors, which is torch, add, torch.sum, etc. However, you may wish to bring a new custom operation to Pytorch and get it to work with subsystems like torch.compile, autograd, and torch. Wait, so you can create your own operators? That's crazy, dude. And torch.vmap. In order to do so, you must register the custom operation with Pytorch via Pytorch, torch library, or C++ torch_library APIs. Okay, so you have to register your own torch. I don't think this is necessary to know for us, because we don't. You obviously can. So it's technically like an open source library where you can add your own operations or operators. But you still have to ask them for permission to add them. That's interesting. Okay, so TL and DR. Authoring a custom operator from Python. Please use Python custom operators. What is this? Large library of operators that work on tensors. This is basically the whole page I was on. Almost. You may wish to author a custom operator from Python as opposed to C++. If you have a Python function you want to Pytorch to treat as an opque callable, especially with respect to torch.compile and torch.export, you have some Python bindings to C++ /CUDA kernels and want those to compose with Pytorch subsystems like torch.compile and or torch.autograd. Integrating custom, yeah, this is stuff we actually don't need to know. So we are essentially done. Let's just try out these save and load module things here. So say for example that we want to save our own. Let's try this out. Okay, so we go to our open operation neural network, and then we do all of this. We test loop and all that stuff, create the optimizers and stuff like that, and we do this, and then we print done. And then after we print done, we also want to create, not load, we want to save the module. So it should be, whoops. It should be, we could actually just do it with this, but it would be funnier to do it with our own custom. So let's do that. I will actually just move all of these away. So we have our open and we want to load. We could actually comment this out and just save it, and then we want to load the module from a different file. We can try that out. So here we torch.save module, and module is defined up here, so we save that while it trains. So let's go and run that first. So let's do that. I can just probably run this, and then I'm gonna run this script and see if this actually works. If this actually saves the module into our lightweight file, we can just load it and use it directly. But I would just want to see if it's actually... Wait, we shouldn't do this then. We should probably do this instead. We should probably save it before we are done, so we know that it actually worked. Clear the whole thing and run this again and see how this goes. also gonna do a list. I might actually create a... Let's go in Pytorch explore documentation for comprehensive guide of how to use Pytorch. Then we have documentation here, the different... Okay, so this is basically the whole thing documentation. Okay. This is all the APIs, community developer notes. This is good stuff to read through. Tools, community, forums. Let's see the forums. Let's see what happens. Now let's check if this is done. It's not done. Okay. So we have data topics related to data loader and data sets, uncategorized, C++, distribution, autograd vision, Windows, MPS, torch.compile, deployment. A category of posts focus on production usage of Pytorch. Mobile development is out of scope for this category for now. You should care if you are looking for a serving solution to ship Pytorch moderators, I think it's called, or mobile. For a serving a solution to ship modules to production, tools to manage modules, working end-to-end managed workflow, job orchestration, tooling, monitoring, debugging, or visualization and optimization. Interesting. Let's see if this is done. It's at the 6th epoch. Let's just take a quick look at what to learn next. Let's go to tutorials. So we have learning Python. I think we are done with all these. I will personally go through these by myself and try to, you know, create a more delicate tutorial for you guys. So we have learning Pytorch, deep learning, and Pytorch a 60-minute blitz. I think this is a video, right? Yeah. This is also all videos, right? Learning Pytorch with examples. So author is Justin Johnson. This one of our older Pytorch tutorials. You can view our latest beginner content in Learn the Basics. I think that is what we did just now. Yeah. So this is a bit older, but that's fine, I guess. So this tutorial introduces the fundamental. It's almost done. Okay, let's see if this actually works. If this works, then hell yeah. Okay, we are in the last epoch here, so it should be done as soon as possible, right? And if it's done, if it's printing down here, we should see a file that is called like module.path or something. So it seems like it's done. Let's see if this module.path is saved. Yep, we have a module.path. Let's try to create our test. So we have our module right now, so let's just create a test.py file here. Whoops. Just press here. Test.py, and then go up here and just add these whole things here, and then we can essentially, I think we just create the different I think we need all of these. No, we don't. We need all of these here, and then we actually need you know what? We actually don't even need these when I'm thinking. We should just import the... We should just load the module itself, so we could probably just write this. Write this whole thing here, and do like something like that, and then just print the module, and we will see if this actually gets the module or not without training it again. So this is how you load the module. So here we save the module that we just trained, and then we can load the module and then print the structure, I guess. I think that's how you print the structure. Let's check. let's test this out and see what happens. So we're gonna clear this whole thing and essentially just ls and type Python 3 tests.py and see if this works. Okay, so can't get attribute neural network on module. Does that mean we have to still have the neural network inside of here? So I might have to... I think I might have to do this. I wonder where it's contemplating line 7. Cannot find attribute neural network on module main. So we need this module before we load it inside of the file. Is that what it's talking about? I think that's fine. We might need some more. Where is this defined? It's not. It's defined here. Okay, that's fine. We don't use these. Let's add these as well, just to be on the safe side. And see if this works. Ah, it worked. Nice. So that is actually how you load the module, and I think we can comment this whole thing out. Perhaps we can probably just do this and run this file again and see if it prints. Okay, so it only needs the class. Good. Okay, so that's all for today, guys. I think that's enough, and tomorrow we will go to... Wait a minute. Tomorrow we should go to this image and video. Torch vision, object detection, and fine-tuning tutorial. So this is basically how you detect people in an image. That is what we're gonna do tomorrow. And here you see all the different... Yeah. It's a very long tutorial, but that's fine. But we will do that tomorrow. So yeah, I hope you guys enjoyed this small live stream. It's only 1 hour, and it's not too long. Either way, guys, thank you for watching, and have a wonderful night.